So if we look at these two problems, we could solve one of them for y, or actually we could even solve both of them for y and then substitute. But there's an easier method than that, and if we notice, here we have a positive y and another positive y. Since they are both the same, we can eliminate that y variable. Since we're adding both terms, or since we're adding y in both equations, that means if we subtract the bottom equation from the top, that means that y will be eliminated or will go away. So if we subtract these two equations, 3x minus 6x will give us negative 3x. Y minus y gives us 0. 3 minus negative 3 is 6. Again, you notice when we added these two equations, or when we subtracted these two equations, we eliminated that y variable. And now we solve this equation for x. So negative 3x equals 6. Divide by negative 3, and we get x equals negative 2. So now we have our x value, and we can substitute that back into one of our equations and solve for y. So negative, if we plug it into the top one, we get 3 times negative 2 plus y equals 3. So we get negative 6 plus y equals 3. Add 6 to both sides, y equals 9. So our solution is negative 2, 9. If we plugged it into the other equation, 6 times negative 2 plus y equals negative 3, we get negative 12 plus y equals negative 3. Add 12 to both sides, y equals 9. We'd still get our solution of negative 2, 9. So what we've done in this step, or in this, we've eliminated the y variable. Both terms had a positive y, so we eliminated the y by subtracting the two equations. So if we look at these two equations, it would be a lot of steps to solve the top equation for y, and it would be a lot of steps to solve the top equation for x. So to substitute would cause us a lot of steps. Same with the bottom one. There'd be quite a bit of steps to solve for, let me make that negative better, to solve for x, and a lot of steps to solve for y. If we notice, both equations have 4x. We have the 4x on top, and we have negative 4x on the bottom. Since the both terms have 4x's, we can eliminate the 4x. Now, since one is positive and one is negative, I'm going to add the two equations. In the previous example, they were exactly the same. One was positive and the other was positive, so we subtracted. In this example, positive 4x, negative 4x, we're going to add. When we add 4x plus negative 4x, we get 0. Negative 2y plus 5y is 3y. 8 plus negative 2 is 6. So again, you can see that when we added the two equations, the x term gets canceled out. And so now we solve for y. We divide by 3. So x equals 2, or sorry, y equals 2. So now we have our y term. So now we plug the 2 into either equation. We plug it into the top equation or the bottom one. It really doesn't matter. Both will cause us the same amount of work. So 4x minus 2 times 2 equals 8. 4x minus 4 equals 8. 4x equals 12. X equals 3. Again, if we plugged it into the bottom equation, we'd still get the same thing. Negative 4x plus 5 times 2 equals negative 2. Negative 4x plus 10 equals negative 2. Negative 4x equals negative 12. X equals 3. So again, it doesn't matter which equation you plug it into, we got x equals 3. So our x term is 3. So our solution to this systems of equation is 3, 2. We got our answer from elimination. We eliminated the x and solved for y and plugged it back in. In our first example, we solved this one by elimination. We eliminated the y and solved for x and plugged it back in to get y.